Hi, this is Xavier. Today we are going to discuss about refraction through a convex and a concave lens. Okay, refraction through a refraction through a refraction through a convex. Okay, convex and a concave lens. Refraction through a convex and a concave lens. Okay, a few seconds we got to wait for it. Okay, so listen here. Refraction through a convex and a concave lens. Okay, you know very well how can you make the convex lens. The two spherical surface will be combined with each other. We will make the convex lens. The two at the same time, the two spherical surface will be separated by the distance. We will make the concave lens. Okay, because the convex lens is a converging lens, concave lens is a diverging lens. Okay, if you know if you need anything, you just go through upon the short answer 6. I think a difference between convex and concave. Okay, they have to given the special points. Okay, because the convex lens is a converging lens, concave lens is a diverging lens. If you consider the convex lens, the center is thicker and the edges is thinner. It is the convex lens. It is treated by using the hypermetropia. At the same time, we got to compare the concave lens. The concave lens is a diverging lens. The center is very thinner and the edges is very thicker. It is treated by using myopia. Okay. So first I will draw the diagram. What is the shape of lens? What is the shape of lens? What is the shape of lens? This is a convex lens. This is a convex lens because the center. Okay, because the two surfaces are bulged. Two surfaces are bulged. Okay, in the O is the optic center. Okay, this is the principal axis. Okay, and F1 is the object. F2 is the image. Okay, the C1, C2 is the center of the C1, C2 is the center of the page. Okay. So we have to quickly recap again. I have to draw the diagram. So look here. Okay. For example, this is a convex lens. Okay. This is a convex lens. Okay. O is the optic center. O is the optic center. This is the principal axis. Okay. So F1 is the object and F2 is the image. F2 is the image. And C1 and C2 is the center of curvature. What is the center of curvature? We know that. Okay, for example, what is the O? O is the optic center. Okay, if you consider any other convex or concave lens, O is the optic center. The straight line is called as the principal axis. So F1 is the object. Okay, F1 is the object and F2 is the image. You have to keep in your mind the object is always placed on the left side, the image will be appear on the right side. Okay, what is the C1 C2? The C1 C2 is the center of curvature. Okay, the two spherical surface. If you consider the two spherical surface, okay, because this is the first surface of sphere C1, this is the second sphere of center C2. Okay, so that's why you have to mention about the C1 and C2. Okay, so this is the center of curvature. Okay, next already you know very well because the lens height it should be mentioned as the aperture. Okay, so now we have to discuss about the refraction through a convex and concave lens. Okay, so we got to work out the four conditions. Okay, I got to create the table column. For example, first object position. What is the object position? Object position. Everyone look here. Object position. Okay, object position. Next, image position. What is the image position? Image position. Okay, image position. Next, size of the image. What is the size of the image? Size of the image. Next, okay, nature of the image. What is the nature of the image? Okay, so these are four cases. Okay, first listen here, if you study about this condition will be very useful for it. Okay, we know that first you know very well about the rules. Okay, what are the rules? For example, this is a convex. Okay, this is a convex lens. Okay, this is a convex lens. O is the optic center. This is a principal axis. Okay, so listen here. Next, this is a concave lens. Okay, this is a concave lens. Okay, this is a concave because the two surfaces are bulged in. Let me repeat. The two surfaces are bulged out. It is a convex lens. The two surfaces are bulged in. It is a concave lens. Okay. So O is the optic center. This is a principal axis. Okay. We know that the F1 is the object and F2 is the image. Okay. Again, the F1 is the object. Okay. F1 is the object and F2 is the image. F2 is the image. The object is always placed on the left side. Okay. So next is the rule one. Listen here. The rule one. Okay, rule one. Note it down, everyone. Because if you know the rule 1, rule 2, rule 3, you can draw the diagram easily. Okay, without any other help. Okay, what is the rule 1? Because the light ray, listen here, the light ray can travel, through optic center. Okay, light ray can travel through optic center. Light ray can travel through optic center. Okay, light ray can travel through optic center. Okay, what is the meaning? Because the light ray can travel through optic center without the deviation. Okay, without the deviation. So listen here. So you have to draw the diagram. For example, this is a convex lens. Okay, this is a convex lens. Okay, O is the optic center. This is the principal axis. F1 is the object. Okay, and F2 is the image. Okay, so the light ray, listen here, the light ray can pass through the optic center without the deviation. Okay, because the light ray can travel through the optic center without the deviation. This is a straight line. Okay, we know that light is a form of energy. Light always travel in straight line. What is the speed of light? 3 into 10 power 8 ms power minus 1. The light, it can be propagated through the air medium. Okay, can be propagated through the air medium or without the medium. Okay, empty or vacuum space. Different color light has a different wavelength. Okay, so this is the rule 1. Okay, next is the same process. For example, this is a concave lens. Okay, this is a concave lens. Okay, this is a concave lens. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. So the light ray can travel through the optic center without the deviation. What is the without the deviation? Okay. Next, this is a rule 1. Okay, this is a rule 1. Look here. Can you understand? Light ray can travel through the optic center without the deviation. So the light ray can travel through the optic center. Okay, if you consider convex or concave lens without the deviation. Okay, this is a rule 1. So you have to carefully listen here. Okay, next. Rule 2. Rule 2. Okay, for example, what is the rule 2? The light ray can travel, light ray can be traveled parallel to the principal axis. Okay, parallel to the principal axis. Okay, principal axis. Okay, for example, this is a convex lens. Okay, this is a convex lens. Okay, O is the optic center. This is the principal axis. F1 is the object and F2 is the image. Okay, F2 is the image. Okay, so you have to read the condition. The light ray can be traveled parallel to the principal axis. Okay, so the light ray can travel. Okay, the light ray can travel parallel to the. Okay, this is because this is the principal axis. Okay, this is the principal axis. So the light ray can travel parallel. Okay, parallel to the principal axis. Again, light ray will be followed on the lens. So the light ray will be bending. So the bending of light ray will be converging at F2. Because the convex lens is a converging lens. Okay, listen here. The convex lens is a converging lens. Okay, the convex lens is a converging lens. Okay, so you will get the image. Real and inverted image. Real and inverted image. Okay, for an example, uh, this is a condition. Okay, for example, this is a concave lens. Okay, this is a concave lens. This is a concave lens. Okay, this is a concave lens. O is the optic center. O is the optic center. This is the principal axis. F1 is the object and F2 is the image. F2 is the image. The light ray can travel through can be traveled parallel to the principal axis. So the light ray can bounce back into the light ray can bounce back into the same medium, because we know very well, because this is a concave lens. So the object and image, listen here, the object and image, okay, the object and image, both are the same side, both are the left side, okay, both are the left side, okay, left side. Can you understand? Because the light ray, okay, the light ray can be diverging, okay, because the light ray can travel parallel to the principal axis. So the light ray will be followed on the concave lens, but the light ray will be diverging. Light ray will be diverging, but the diverging light ray will be converging at F1, because bounce back into the same side. Okay, so we will get the image, because the concave lens is a diverging lens. Okay, concave lens is a diverging lens. So it appears to diverge from, listen here, it appears to, note it down the point, it appears to diverge from, principal focus, okay, principal focus F1. It appears to diverge from principal focus F1, because the concave lens is the diverging lens. Okay, we will get the image virtual and erect. Okay, we will get the image virtual and erect image. Okay, for example, this is a rule 2. Let me repeat. If you consider the convex lens, the light ray can travel parallel to the principal axis. So the light ray will be followed on the convex lens. Then the light ray will be bending. The bending of light ray will be converging at F2. So we will get the image real and inverted. Okay. Next, you have to consider the concave lens. The light ray can be traveled parallel to the principal axis. The light ray will be followed on the concave lens. So the light ray will be diverging, because it appears to diverge from the principal focus F1, because the object and image both are the same side on the left side. So we will get the image virtual and erect image. What is the meaning of virtual and erect? It is a shadow. Okay, because the shadow does not appear on the screen. Okay, this is a rule 2. Okay, next rule 3. Listen carefully. Rule 3. Okay, so we have to write the condition. Okay, the light ray can be traveled through principal focus, okay, so we got to draw the diagram. For example, this is a convex lens. Okay, this is a convex lens. O is the optic center. This is the principal axis. F1 is the object, and F2 is the image. Okay, so read the condition. Light ray can be traveled through the principal focus. Okay, so we got to increase the lens size. Okay, this is a convex lens. Okay, so we know that the light ray can travel through the principal focus. Okay, we know that the convex lens. Okay, the center is very thinner. Okay, the edge is very thinner, and the center is very thicker. Okay, so the light ray can travel, and the light ray can be followed on any other edge or any other center. So the light ray immediately refracted or bending. So the bending of light ray is also called as a refraction. Let me repeat. The bending of light ray is also called as a refraction. Okay, so the light ray will be so let me repeat. the light ray parallel to the light ray can travel through the principal focus. So the light ray will be followed on the lens. So the light ray will be travel the straight line, okay, parallel to the straight line, okay. Can you understand? This is the rule 3. Light ray can be traveled through the principal focus because we have to consider the convex lens. So the light ray can travel through the principal focus. So the light ray will be followed on the lens. So the light ray will be followed on the edge. Okay. So immediately the light ray will be travel through the straight line through the principal axis, parallel to the principal axis. Okay. Next, you got to consider the concave lens. What is the concave lens? Concave lens. O is the optic center. Okay, O is the optic center. This is the principal axis. F1 is the object and F2 is the image. Okay, F2 is the image. So note it on the condition. Okay, because the light ray. Okay, this is for example. Okay, this is the concave lens. We know that the concave lens is the diverging lens. Okay, so the light ray. Listen here. The light ray. Okay, this is the concave lens. So the light ray can travel parallel to the principal axis. Okay. Wait. Sorry. Listen here. The light ray, okay, the light ray can travel, parallel, travel to the principal focus, okay, principal focus, but the light ray will be diverging, okay, this is because the concave lens is a diverging lens, okay, let me repeat, the light ray travel through the principal focus, the light ray will be followed on the lens, so the light ray travel parallel to the principal axis. This is a rule 3. Okay. Next, you got to consider the concave lens. We know that the concave lens is a diverging lens. We have to get the image, virtual and direct image. It is what is the meaning of virtual and direct image? It is a shadow. Okay, it is a shadow. So the light ray travel through the principal focus, but the light ray will be diverging because the light ray will be bouncing in the same side again. Bouncing to the same side. So the object image on the left side. Okay. Okay, thank you.